Picture this. Beneath the waves of our planet's oceans, an intelligence that rivals our own is flashing messages we cannot comprehend, building structures we've never imagined, and solving problems in ways that would revolutionize human technology. What if the most alien minds on Earth decided to stop hiding in crevices and started building civilizations instead? Today, we're diving deep into one of the most mind-bending scenarios in speculative evolution. What would happen if octopuses developed complex language and technology? Right now, as you watch this video, millions of octopuses are demonstrating feats of intelligence that would make most mammals jealous. The common octopus possesses around 500 million neurons distributed throughout its body, with 2/3 of these neurons located not in its brain, but in its 8 arms. Unlike humans, who centralize intelligence in one location, octopuses operate with what scientists call a distributed intelligence network. Essentially, each arm can taste, touch, and even react to stimuli independently, while communicating with the central brain. These remarkable creatures already exhibit behaviors that hint at the foundations necessary for complex societies. Recent research has documented octopuses using tools, with Indonesian veined octopuses carrying coconut shell halves as portable shelters, and even stacking them for later use. They demonstrate learning capabilities that include trial and error problem solving, memory formation, and what researchers call cognitive flexibility, the ability to abandon ineffective strategies and try new approaches. Perhaps most intriguingly, scientists have observed octopuses engaging in complex color pattern communication, with males and females using sophisticated visual signals during social interactions. The evolutionary foundation for octopus intelligence is already extraordinary. These cephalopods diverged from vertebrates over 500 million years ago, yet independently evolved large brains and complex behaviors comparable to those found in birds, dolphins, and primates. Unlike the social intelligence hypothesis that explains brain evolution in mammals, octopus intelligence appears to have evolved through what researchers call the asocial brain hypothesis, intelligence driven by the need to navigate complex ecological environments rather than social structures. This ecological pressure created minds capable of rapid adaptation, sophisticated camouflage that can mimic dozens of different species, and problem-solving abilities that consistently surprise researchers. Now, let's imagine our speculative scenario beginning to unfold. The catalyst for octopus language and technology development might emerge from an environmental crisis that forces these typically solitary creatures to cooperate. Perhaps rising ocean temperatures or changing currents create resource scarcity that makes their current hunting strategies insufficient. In this scenario, octopuses begin forming temporary alliances, sharing information about prey locations and predator movements through their existing color pattern communication system. The first breakthrough would likely come through the evolution of their chromatophore system, the specialized skin cells that control color and pattern changes. Currently, octopuses use these for camouflage and basic communication, creating patterns that signal aggression, mating readiness, or territorial claims. In our speculative evolution, selective pressure for more precise information sharing would drive the development of increasingly complex chromatic vocabularies. Imagine octopuses developing the equivalent of visual words with specific color combinations and patterns representing concrete concepts like dangerous shark nearby or abundant crabs in Eastern Territory. The distributed intelligence of octopuses would give them unique advantages in developing this visual language. Unlike humans, who process language primarily in specific brain regions, octopuses could potentially develop localized language processing in each arm, This might allow for something unprecedented in Earth's history: simultaneous multi-channel communication. An octopus could display different messages on different parts of its body, engaging in complex conversations with multiple individuals at once, or even holding internal dialogues between different neural centers. As their chromatic language grows more sophisticated, octopuses would face the same evolutionary pressure that drove human tool use and the need for increasingly complex problem solving. Their remarkable manipulation abilities, with arms containing thousands of independently controlled suckers, would make them natural engineers. The transition from carrying coconut shells to crafting purpose-built tools would happen gradually, driven by their existing capacity for learning and innovation. The development of octopus technology would likely follow pathways completely foreign to human engineering. With their soft bodies and aquatic environment, they wouldn't develop metallurgy or fire-based technologies. Instead, they might become masters of bioengineering, cultivating and modifying other marine organisms for specific purposes. Picture octopuses domesticating certain species of algae to create living building materials, or breeding specialized electric eels as power sources for their settlements. Their natural ability to change body texture and color could evolve into sophisticated biotechnology, perhaps allowing them to grow specialized organs for different tasks. The social implications of octopus civilization would be fascinating to consider. Their current semi-social behaviors, observed in species like the gloomy octopus in Australia, suggest they can already navigate complex social hierarchies and territorial arrangements. A technological octopus society might organize around temporary expertise-based coalitions rather than permanent social structures. Imagine octopus corporations forming and dissolving as needed, with individuals joining groups based on complementary skills and then disbanding once projects are complete. Their unique sensory capabilities would create technologies we can barely imagine. Octopuses can taste and smell through their skin, detect polarized light, and sense electrical fields. A technological octopus civilization might develop taste-based computing systems, where information is processed through chemical gradients rather than electrical signals. Their ability to rapidly change body texture could lead to architecture that reshapes itself in response to environmental conditions or social needs. The implications for human contact with such a civilization would be profound. We might discover that octopuses have been observing and analyzing human activities for generations, using their incredible camouflage abilities to study our technology and behavior without detection. Their distributed intelligence and unique sensory systems might allow them to perceive patterns in ocean currents, climate systems, and even human behavior that completely escape our notice. Perhaps most remarkably, octopus civilization might develop along completely sustainable lines from the beginning. Their evolution in complex marine ecosystems, combined with their relatively short lifespans and rapid reproductive cycles, would create strong selective pressure for technologies that work in harmony with ocean environments. Rather than exploiting them, they might become the first technological species to achieve true ecological balance, creating innovations that enhance rather than deplete the natural systems they depend on. The scientific plausibility of this scenario rests on octopus's already demonstrated capabilities and the environmental pressures that could drive their enhancement. Current research shows these remarkable creatures possess nearly all the cognitive building blocks necessary for complex civilization. Advanced problem solving, tool use, communication systems, learning ability, and even elements of social cooperation. The question isn't whether octopuses could theoretically evolve these traits further, but rather what environmental circumstances might drive such rapid evolutionary change. Climate change and ocean acidification are already altering marine ecosystems in ways that could create intense selective pressure on cephalopod populations. If these changes made traditional octopus survival strategies ineffective, the species might face an evolutionary bottleneck that favors individuals capable of more complex cooperation and innovation. Given their impressive learning abilities and short generation times, octopuses could potentially evolve new behaviors and even physical traits much more rapidly than longer-lived species. Standing at the edge of this speculative ocean, we're reminded that intelligence takes many forms throughout the natural world, and consciousness might be far more common than we've traditionally believed. The octopus mind, with its distributed processing and alien sensory capabilities, represents a completely different approach to complex cognition than anything in our human experience. Whether they develop technology or not, these remarkable creatures are already demonstrating that there are multiple pathways to intelligence in the universe, each potentially leading to forms of awareness and capability we're only beginning to understand. The next time you see an octopus gracefully flowing across the ocean floor, consider that you might be witnessing one of Earth's most sophisticated minds at work, an intelligence that could, under the right evolutionary pressures, reshape the very concept of what it means to be a technological species. In the vast theater of evolutionary possibility, the octopus story is far from over, and the next chapter might be more extraordinary than anything we can imagine.